Hey, welcome back to part 3 of the Identity.com showcase.
So you wanted to know how does the actually manipulation of the DID state work?
Let's pretend you lost that key.
So
or let's not, if you lose the key before you've added a second key, you're in trouble.
Exactly, you're in
trouble.
trouble.
You want to make sure that you're able to lose
Exactly,
the key.
you're able to. You want to get a setup for multiple access methods.
Got it.
Let's say I want to connect my phone key.
You want to add your phone. This is usually not something I would expect a wallet to be able to do.
Exactly. Or only to do with like transferring your passphrase in an insecure fashion. So the Solana, the DID Sol client is specifically around resolution of DIDs. When it comes to manipulation of DIDs and using DIDs on Solana, then Cryptid is your friend. Okay? So we use Cryptid and we install the Cryptid CLI for this.
Okay, so there's a CLI. This is the CLI or command line interface version of the graphical user interface you saw at the start of this presentation, right?
Exactly. So the concept should be familiar. Exactly.
Yeah. Although we've been talking for quite a while now, they may have forgotten. Let's not assume.
They may have.
Okay.
So I just installed the Cryptid CLI, and the first thing we do is we initialize the configuration. And it infers, if you don't have a config yet, that you want to use your Solana key as your default configuration. So I can actually print that here. And you can see that it uses the default key, and it uses also DevNet that we want to work against.
Okay, so we've got another address here that isn't the same as your public key.
Exactly, and that was what we were referring to before. Your on-chain representation is actually now different from your public key address, because that is
because it may not always stay the same if you change keys.
Exactly. So we need that stays the same, independent of how your DID state changes or how your Cryptid state changes.
Got it. Okay. Okay. Let's add a key.
Okay. So there's one convenience method, or if I type it correctly. So I can resolve the document with Cryptid as well. Cryptid already knows that I set up my account, so you see the same information as with Solana.
Okay.
So now, if I want to set up a key, I actually need some Sol because I start having transactions. So
that was earlier on that DID was inferred, but of course, as soon as you add something to it, you're going to have to store that somewhere. Right, and that means making a transaction on chain.
Exactly.
Okay, so you only need to make a transaction on chain
if you change from your default state.
If you change from the default state. Great.
Exactly. So let's create another key, and we actually use Solana keygen for that. Keygen. And we actually output that as a key 2.
Okay.
New.
Yeah, new.
That would be a good help.
Yeah, I knew I missed something else as well. All right. Okay, we've got key 2, but it's just sitting there.
It's just sitting there.
Yeah.
It has a inferred Cryptid address as well, but that's not what we want to do with key 2.
It's going to blow my mind.
We want to actually add key 2 to my existing Cryptid address. So since Cryptid has the config persisted, all the commands I'm doing with Cryptid are inferred with my initial CFC address. Okay.
Got it.
So I'm calling Cryptid key add, and I want to add the pub key that I just created, where you see I don't work with any private key material in order to authorize a key, and I'm going to give it an alias.
All right.
So what's happening now is Cryptid will generate a transaction on chain to add that key. And in order to show you that this is all working, we should be able to resolve that in...
there's 2 keys there now.
At the unit resolver, and we see 2 keys. So we see our CF initial key, and now we see our 2UV,
That's cool,
the key
because
that we just added.
Uniresolver doesn't know what Solana is.
Exactly.
I mean, somewhere back deep in the depths, there's something resolving that Sol did, but this.
But it only has a very tiny knowledge of DID Sol.
Yeah, it's just like any other method.
Exactly.
But the Cryptid application has. Okay, cool. Let's go back and have a look at the DID document.
So we could do that with Sol, but we just use our document command,
Yeah.
which should give the same information.
Okay, so I see two. We're not going to go into all the details of what each of the different parts of the did mean, right? But we see two verification methods, we see two capability invocations, and they have this default and key 2. Okay, so now you can imagine, and the thing I found interesting about that last bit was you used the original key, the original private key, presumably behind the scenes in the cryptid, to add the public key of key 2. But you didn't need the private key of key 2 to do that. So you could have created that public key on some other device and just passed it over. Right?
Exactly.
You could create it on your mobile. You have a mobile wallet. You want to add it. You want to add it to the same account as your desktop wallet. You just have to pass the public key from your mobile to the desktop, and then the desktop key can add it to the DID.
Exactly, and people are often asking, how is this more secure if this is like this abstraction on top of a wallet? How can this be more secure? Well, not sharing private key information is a big security aspect in order to authorize someone else or some other device or some other person to your account.
So can I sign transactions with key 2 now?
Yeah, totally. There are multiple examples that we could do now. Like this demo actually shows you that you can use key 2 to remove key 1. But we could also transfer funds to key 2. So the first thing that we need to do is, again, key 2 is a new key, so it doesn't have any funds. So what we do...
And why does key 2 need funds?
Because I want to show you executing transactions as key 2.
Right. So we'll be signing. We'll be paying for the the gas, right? The fee of the transaction with key 2 this time.
Exactly.
But the overall funds, the funds that are in the wallet itself, they're all still in the cryptid account, the abstraction account. Got it.
Correct. So what I'm doing now with this command...
You did an F in transfer, but apart from that... Sorry, that's not meant to be rude. You need an F in transfer.
Transfer.
F in
So
transfer.
what I'm doing now, I transfer from my cryptid account, which was airdropped before, to the key 2 account so that I can execute transactions with
Got
that
it.
account.
Okay. It's getting a bit abstract.
It's getting very abstract.
But this is...
Do you want to look at the transaction on chain?
No, I trust it. I trust it.
Okay. So now what we could do is we could configure Cryptid to actually use key 2 and not the default key anymore.
Okay.
So we update the config by setting our key file 2 into the config. So all the Cryptid commands that I execute from now on, let's actually make sure. I think that is the right location.
Okay.
So all the commands I'm doing with Cryptid now, I'm doing with the private key material of Cryptid. So one command I could do is I remove the access from the first key, the initial key called default key.
Okay. So if you suspected that default had been compromised, you left it on a bus or something like that, then you could now remove it, effectively rotating the key.
Exactly, and that doesn't mean that my identifier changes. The initial default key is still very unique in that it is part of my identifier, but it is not authorized to do any operation anymore.
Okay.
So let's do this transaction, and this transaction is signed with key 2.
Got it. Okay.
So after this operation, if I look at the document again, you will see something special. So one thing you will see is that the verification method...
It's still there.
It's still there, but that actually doesn't define access. Because this is this initial special key, it still shows up as a verification method, but you can see that the capability invocation that previously had key 2 and the default key now is updated to only have key 2.
So I can't sign with default anymore.
You cannot sign with default anymore.
All right, I want you to prove it.
Okay, I prove it.
It's convenient that you've already got the command.
Yeah, it's a long command. So what I'm doing now is I set the config back to the key I had previously.
Okay, the default key.
The default key.
Yeah.
So all cryptic commands are with the default key. And let's actually do the transfer we just did before. So the transfer.
So now you're an evildoer that's stolen the default key,
Exactly.
and you're trying to use it. This had better not work.
That better not work. Let's see.
Hey, it's
God.
a well-known Solana error.
So it somehow like failed out on verifying keys, which is
Yeah.
exactly the error that we wanted to see.
Successful failure. I would
Successful
say.
failure. So what we can do now is change it back.
Okay.
So that we
are
can
you
do
are you
something
scared
again.
about the // on the key?
I am scared about the // I'm actually interested in.
All right, there we go.
All right.
Okay, that was part 3. There's still more to come, so come back and see us for part 4 of the Identity Showcase.